y'all think it was pretty close to homework?
Mm-hmm.
Yeah, pretty close. All right, and I'll grade those and try to get them back to you as quick as I can. Properties quiz is going to happen week 9. Raise your hand if you've been on my teacher page and you found the Quizlet, you found the video, you found the little sheet, okay? If you start it early, it's going to be better for you than if you wait till the night before that quiz, okay? Because it takes a little while to remember these. And I don't know about y'all, I have a hard time memorizing something if I don't understand what it's even talking about, right? So if you watch the video, hopefully you'll understand them a little better and you'll be able to memorize them, okay? And we'll start working on them in class too, but that's coming up at week 9. All right, today we're going to start with sections 3.1 and 3.2, the distributive property. Have any of y'all ever heard of this property before?
Mm-hmm.
You have?
Yeah.
Well, maybe we don't need to do this then.
Okay. Hold on, will we actually get to eat the candy though?
Yes, but at lunch. Don't eat it in here now. Wait till lunch. Because I'm just a mom and I'm mean like that. It happens. All right, so what we're going to do is I'm going to distribute candy to you.
Yay!
This is free. You get to eat candy
Yay!
at lunch.
Oh.
Let me get the candy going.
Our teachers are bribing us with food today. They're about to give us popcorn. They're giving us candy.
Hey, you know if it works? It works. You can choose. Well, actually, you know what? I'm just going to hand out my Kit Kats right now, okay?
Yay!
Yes, I'm going to hand out the Kit Kats first, so I'm going to go around. And I'm just going to toss them to the people in the back.
You missed him.
Here you go, Savannah. I missed somebody. Do you mean I distributed candy, but I didn't distribute it to the first person there?
Yeah.
Wow, that is terrible. I'm sorry I did that, Jackson.
And just continue to ignore him.
We're going to learn about the distributive property in a minute. And the most common error is people do not distribute it to every term inside. Jackson will always remember to distribute it because he got left on the candy. Okay? So we may actually, if you don't quite get the lesson, have to do that again a little later.
Yeah.
To make sure. Savannah's thinking
I didn't get it yet.
That's what I was thinking. We may need to do that again just later. But put your candy to the side and we'll talk about that in just a minute. Okay? Go ahead and get your notebook out.
It's in plastic.
But it still smells like chocolate.
It does. It smells good, doesn't it? Let's go ahead and write down example 1.
Are you doing this for your birthday? Nice?
I always do candy on the day that I teach distributive. In fact, my sons, no, they're like, Mom, you're buying candy? Because I never do that. And they're like, you must be teaching distributive property. I'm like, yep. Okay? Because you know what? You'll remember it, or at least I hope you will. But like Savannah said, we may just need to do it one more time. All right, go ahead and write down example 1. You're going to write 5, parentheses, 2x plus 3, and then close the parentheses. So 5 times the quantity, 2x plus 3. Yes, ma'am?
Are we allowed to start solving this?
No, hold up just a minute. I want to talk about it a little bit. Because you may have done it and know how to do it, but you may not know why it works the way it works. So let's talk about it. If you were going to do the problem, and you don't have to write this here, 5 times 2, that literally means you have 5 2s. Right? But when you were little, you memorized 5 times 2 is what? 10. You don't have to write out that whole addition, do you? Well, that's the same thing that this means. This really means I have 5 2x plus 3's added together. But a lot of times I'll see students and they'll say, well, I've got 5 2x's, and they'll forget that they also have 5 3's. I draw these little arrows when I first teach this. Now, if you've learned this before and you don't need that, then don't do it, okay? But draw some little arrows on your paper right now to show that I have 5 2x's, okay? So I've got 5 2x's, and then I'm going to add to it 5 3's. I want you to show that step. So go ahead and write it down. 5 2x's and 5 3's. Well, what is 5 2x's? Well, you did a lesson where you had to associate and commute. Here, I've grouped the 2 and the x, right? 2 times x. But I could regroup it to where I've grouped the 5 and the 2. I just associated it, didn't I? So what is 5 times 2? 10. So this is just 10x plus 15. There's nothing else I can do there because I can't add these two together. And that's my answer. Okay? Now you don't have to write this step out. You can go straight from the problem to this step. So on homework, copy the problem and then go straight to this step. Okay? But the key is remembering you have 5 of both terms. Yes?
Wouldn't like 5 also, like you have 5 x's?
Well, that is, if you think about it, when you're saying this, Tiffany, means I have 2 x's. This is 2 times x. So when I'm multiplying the 5 by the 2, I am multiplying the x. Okay? That's a good question. All right, this is called the distributive property of multiplication over addition. But will it work over subtraction? Go ahead and copy the next problem down. Negative 3 times the quantity 2 minus 4x. What do we know subtraction is the same as?
Addition of the opposite.
Adding the opposite. So I can change this to adding the opposite if I want to and leave it as that. Might put some parentheses around that so I don't lose my negative. Okay. Some of you may not need to do that. That's fine. Okay. Now when I distribute the negative 3, I'm going to do negative 3 times 2. Anybody, what is that?
Negative 6.
Negative 6. I'm going to bring down my plus. Okay. And then I've got a negative 3 times a negative 4x. What's that going to be?
12, positive.
Yes, positive. A negative times a negative is going to be a positive, and that's a 12x. Okay? And when you work that out, that's as far as you can go. Now somebody may say, is that the same as 12x minus 6? It is. We can rearrange those because we've got an addition. We can put the 12x first. But the key again is distribute to both terms. Most common error would be to say this one is 10x plus 3. Didn't distribute to the second term. The common error here, they wouldn't distribute to the second term. So make sure, just like I skipped Jackson on the candy, got to make sure you distribute to every term. All right, go ahead and copy down example 3.
But why did you choose Jonathan? I mean, not Jonathan, Jackson.
Yeah, he was right there. I just said, it'll be Jackson today. Every year, another person gets to be blessed by missing my candy. But I always give it to them in the end, okay? All right, so copy down negative 1 times the quantity, x minus 5 minus 7. What is being distributed in this problem? No, you say. What's outside the parentheses?
Negative 1.
Negative 1. Negative 1 is being distributed. Now, if it helps you with the signs, I would change this to adding the opposite. Okay? With a pencil, if that's too close to the 5, you're going to forget about it, so you might want to put it in parentheses, but hopefully with the chalk, we can see it. Okay? Now, I'm going to distribute the negative 1 to the x. What will I write down?
Negative x.
Yes. Okay? Then I'm going to bring down my plus sign. Okay? And then Autumn, I've got a negative 1 times a negative 5. What am I going to write down?
5.
Yes, positive 5. Okay? Then I'm going to copy down what was already there, which is the minus 7. This one has one more step to it. Okay? Will, what would you do next?
Subtract 5 and 7.
Yeah. So I'm going to copy down the negative x or opposite of x, and I'm going to do this 5 minus 7, which would be plus a negative 2 or just minus 2. Either way is fine. And that's what you get for your answer. Okay? So again, make sure you distribute to both terms. Now, I want you to copy down example 4. 6 minus 2 times the quantity 4x plus 3. write down what you think would be the first step for this problem. Just the first step. What do order of operations say that we need to do first? Parentheses. Can we do 4x plus 3?
No.
We can't. Okay, so we can't do that. What would we do next then if we can't do that?
6 minus 2.
Okay, well, that's a subtraction, right? Do we have any other multiplications?
Mm-hmm.
We do. There's a multiplication here. And in fact, if you can't do what's in the parentheses, and there's a number here to distribute, that becomes getting rid of the parentheses, which is just like if you were able to do the inside, okay? So the most common error is people will do this first and bring down a 4. It's not, because this 2 has to be multiplied by this. So draw arrows from the 2 to the terms after it.
So it's pedamas.
Now I'm going to carry down my 6, and I'm going to go ahead and distribute this. Remember, this is adding the opposite. So I'm going to bring down a plus. What is negative 2 times 4x?
That would be negative 8x.
Negative 8x. Okay? So negative 2 times 4x is negative 8x. And then I've got plus, Jackson, I've got a negative 2 times a positive 3. What am I going to write?
Negative 6.
Negative 6. Now, we got a whole bunch of stuff up there. Let's see what we can do to kind of clean it up a little. Chloe, do you see any things here that we could commute and associate and put together?
The 6 and the negative 6.
Very good. This positive 6 and this negative 6 just cancel each other out. So the only thing that's left is negative 8x.
I got positive 8x.
You did. I wonder if when you distributed here a negative times this, did you leave this minus? If you leave it minus, you still have to think of it as a negative 2 times that. That's why it's a good idea to change it to adding the opposite. Okay, it'll help you with your signs.
It just helps me realize I needed to cancel it out.
Yes, yeah. Now, I think I told y'all this, but this will remind you, I don't get just a second span. When my teacher, when I was in middle school, high school, whatever I took this the first time, she always made us use a different color pencil to change things to adding the opposite, because she said it will force you to recognize the sign change. Do that if that helps you, or a highlighter, or whatever helps you. Savannah.
How can we use the symbol for the 2 where we wouldn't usually? Like if that was just a normal thing, like 4 plus 3, we would do 4 plus 3, which is 7, times 2, and then you would subtract from 6. How come we don't do that here?
Okay, so are you saying, I want to make sure I understand you. I'm going to write it the way it was first. Okay, now say that to me slowly again.
If it was a regular problem without an x, we would do the 4 plus 3 first, and then we would multiply it by the 2.
Okay, hold up. I'm gonna write what you said. You said if it were the same problem but didn't have the x, why wouldn't we do this first?
Yes, and
Yes.
then multiply it by the 2, then subtract.
Okay, because we can't add those first, because this one has an x. Now let's think about our commuting and associating. That is a really good question, okay? And so I want to make sure you understand that hits at the heart of a lot of things people mess up all the way through Algebra 1 and 2. So I want to make sure I answer her clearly, because it's a really good question. The operations involved in this, okay, you've got a multiplication here and you've got an addition. When we commute and associate, we can only do that if it's all multiplication or all addition. When you mix the operations, you can't do that. So 4x plus 3 cannot be done unless you know what x is. Does that, do you see what I'm saying?
That's not necessarily what my question
Oh,
is.
okay.
My question is more about the symbol for the 2. Why does the negative sign stay with the 2? Because if you did it the other way, it would be 7 times 2, and then you would subtract that.
Okay, so you're saying, okay, I'm sorry, I missed that.
It's
Because I was
okay.
so excited, I thought you were asking the other question. That's okay. All right, so you're saying we would do this first, and then we would do this, right? And then we would multiply this. That sign is being carried with the 2 there. Okay? Let's just watch for a second. If I ignore it, I could say 6 minus 14. It's still there. Okay, let's think about it, but let's think about it this way with this one. Okay? Let's think about it this way for this one. Let's go here and let's, ooh.
More candy?
Yeah. If I ignore it here, it's the fact that I was able to combine this and then apply the negative later. Here, I can't apply that later over two terms. I would have to keep the parentheses. That is like a really deep question that no one has ever asked me, but that's a really good question. But that's part of the reason is because you've got something here. This is part of this. Here, I'm able to apply it later because it's not like this became plus. It's still there. It's just we're able to deal with it later because we're able to simplify this to one number and then apply the minus. Okay? But here, I can't do that. So if I were to ignore it, and do that, I would have to keep those parentheses. Because that would have to be applied to that one number, but it's not one number. Does that make sense?
Yes.
That's tricky. That's a really tricky question. And if you didn't understand Savannah's question, it's okay, because I didn't at first either, but we got it. Savannah, are you comfortable with that?
Yes, I think I understand.
Okay. Yes, Tiffany.
So, like, what I did was I just swapped the 8x and the 6, and that's how I, like, ended up with a positive.
You swap the 8x.
Like, I commuted the 8x and the 6, changing places.
These?
No, the other two.
These two. You can commute those because there's addition. It would look like this.
No, but what yeah.
But you left your sign.
Yeah.
So then you commuted a subtraction problem, which you can't do unless you rewrite it as adding the opposite.
Yeah.
Yeah. But that's good.
Okay.
You're digging. Y'all are asking some really good, that's a good question. Okay? All right. So yes, you can commute, but only if it's all addition.
Okay.
Okay? All right. Any other really good questions? Tiffany.
Can we eat our chocolate?
No, not until lunch. All right,
It's a really good question.
oral practice. We're going to skip this because of time, but y'all had some really good questions. Homework, I just want to look at that really quickly because there was something about the fractions that I thought might be a little tricky. So let's look, open your book to 3-2. 3-2.
Is it page 96 or 95?
Let's look at 95. Look down at number 16. What are you distributing on page 95, number 16? Let everybody look for just a second. Jackson?
The reciprocal?
You are, well, not the reciprocal.
Just 6.
Oh, well, it's 1/6. So if you're distributing 1/6, you are multiplying through everything by 1/6, which is like dividing by its reciprocal. Okay, so Jackson said reciprocal, but we would have to say dividing by that. So look at 16. Multiplying each term by 1/6 is like dividing each of the terms by 6. Okay, so you see this property also works with division if you're able to rewrite it as a multiplication. That can be a little bit tricky, so we're going to do a fraction one here in just a second. So let's go ahead and write down section 3.3 in your notes and copy down example 5. All right, example 5 says 2x times the quantity x minus 7.
I have a question.
Yes, ma'am.
Like, would it be like 2x times 7, which would be 14x?
That's part of it.
And then the other one would be to the second power x.
Yes. So we're going to distribute to both terms. So go ahead and draw your little arrow thingies to remind you. Eventually, you'll get to problems where there's a whole bunch of terms and you have to remember every single term, okay? All right, so I'm going to do 2x times x. X plus x is 2x. I'm going to write that to the side. This is another common algebra error. But x times x is what? X to the second power. That's really a really common problem. Okay? So when I do 2x times x, it's like I'm commuting, or I guess associating the x times the x. So that's 2x squared, because x times x is x squared. So write your 2x squared down. Jamie, can you think what I would do next?
Do 2x times -7?
Yes. And so I can think of this as adding the opposite, which would make this adding 2x times -7, which would be -14x.
Why wouldn't you just leave it as minus?
You can. A lot of times I won't rewrite it as adding the opposite if this number is positive, because then it's kind of straightforward and I can leave it as a subtraction. But if that number is a negative, I will rewrite it, because then I end up messing up my signs. Okay? So you could, and this is the same as 2x squared minus 14x. A lot of algebra is learning to recognize different ways of writing equivalent quantities. Okay? Jamie, you made a face. What? You got a question?
Can't you simplify that more?
Ooh, now that's a good question. And x squared, if you think about it, if we drew it, x squared would represent the area of a square, where each length is x. But x represents a linear length. So x squared and x are two different things. Okay, that's a really good question. If I had 2x squared minus 14x squared, I could do that. Or if I didn't have the squared, I could do that. But squareds and x's to the first are two different things. And we're going to learn that more in a section coming up pretty quickly. Okay? Really good question. Man, I'm telling you, I've taught this for a while, and some of the things y'all are asking are just awesome. Okay? All of them, actually. All right. Copy down example 6.
Including the candy.
Well, I expected that one. All right. 8x minus 12y plus 20 divided by 4. 8x minus 12y plus 20 divided by 4. My first question to you is, why is this even in this section? What are we distributing? Because it doesn't look like any of the rest of these problems. Give you a second to think. What are we distributing? Think about something Jackson said a minute ago. Savannah?
The division of the 4.
Yeah, dividing by 4 is the same thing as multiplying by what?
1 is reciprocal.
1/4, the reciprocal. So this is really the same as that. So if it helps you to think of it this way, think of it that way. If it helps you to think of it this way, think of it that way. I would probably stay here and just divide every term by 4. Okay? So let's do that. What is 8x divided by 4?
2x.
What? Then I bring my minus sign down. 12y divided by 4
3y.
plus 20 divided by 4.
5.
5. 2x minus 3y plus 5. Now I could do the same thing here. What's 1/4 of 8x?
Oh,
2x. What's 1/4 of 12y? I bring my minus sign over. Minus 3y. Bring over my plus. 1/4 of 20 is 5. They're the same. Doesn't matter which way you think about it, they're the same. Okay? Alright, I am going to need to skip example 7. I will say this. It works the same no matter how many terms you have. Watch when you distribute negatives. Okay, but we're going to skip that one. And I do want to look at example 8 for just a second. So copy it down. Example 8, there's a negative or an opposite sign, and then the quantity 4 minus x.
I now understand it.
Good. Good. What is on the outside that we're distributing?
The negative sign.
A what?
The negative sign.
There is, but there's something else there, you just don't see it.
-1.
A 1. It's a -1. So write that in. That's the same as distributing a -1. Now I want you to write down what you think that would be if you distributed the -1. Chloe.
-4 minus -x.
Alright, so she said
Negative
-4
4 plus x.
minus, and then a -x. So she brought her minus over, multiplied this here, and I would agree with her. We can simplify it a little bit and say that's -4 plus positive x. Okay? You also could have rewritten this as adding the opposite and said that's -4 plus positive x. Either way. You just need to be consistent and do it the way that makes the most sense to you. All right, I want you to look at page 100 in the book. Bless you. There are some problems on page 100 that I do not like. First of all, I have a bone to pick with math teachers back throughout eternity. I don't like that they call them problems. Because it makes everybody think, oh, I've got 40 problems. And that's a lot of problems to have, right? Problems? Why do we call them that? We should call them opportunities. You have 100 opportunities this week to learn something new, right? I'm going to write a textbook. I'm going to call them opportunities, okay? All right, but look at page 100 at the oral practice opportunities. I do not like these. These are real problems, okay? Because they didn't put any variables in them. And they're trying to get you to use this skill to distribute to numbers. Would we do that?
No,
We wouldn't do that. Look at A. What would you do first there?
just do what's in parentheses.
Yeah, you do 3 minus 7. Why distribute it if you do not need to? It will work. So I do want to show it to you. If I did 2 times 3 plus 4, okay? Let's do an order of operations. Look up here. What is 3 plus 4?
7.
7. What's 2 times 7?
14.
Okay, let's do it distributive property. Okay, I'm going to distribute 2 times 3 is 6, plus 2 times 4, which is 8,
Which is
and I
just
get
harder.
14. Okay? After I teach this lesson, I end up getting a bunch of students who'll start distributing these all the time. And it's okay, you're just practicing the skill. But this is really easier.
Mm-hmm.
Okay? So only use that distributive property if you need to. It's a tool that you can use, but you do not have to use. So we're not going to do that oral practice. Tiffany.
I think like the reason they do that is just to demonstrate that you'll get the same answer and to make
Probably.
sure that like you don't get it wrong.
Probably, but I think that's kind of an over, but that's okay. All right, so look at the opportunities in this section. You're going to be doing the evens like normal. Make sure that you watch your signs and that you distribute to every term. That's where your errors are. Now I'm going to beg you here, okay? Begging. Do one problem and then check it. Do not do this whole section, because I'm telling you, this is a section that if you do the whole section and then check it, you could be a very unhappy individual. And I want you all to be very happy individuals, okay? So one and then check it. The point is not to just get done with the homework. The point is to learn how to do it correctly. And if you will use the video correctly, you will do that. Yes, ma'am.
Do you want us to be happy for our families?
Well, I think all the way around. Okay? I think all the way around. Okay, I had written down also, we were supposed to go over some ITED, but we are almost out of time there. I did want to show you, but I think I will post that. Geometry ones from last week, y'all are like good at geometry.
Like good or good?
Really? Well, I would probably say good. Okay? Y'all are good at geometry. Y'all did really well with that. So I don't really feel like we need to really go over that. I will throw a couple things out at you because I have like 2.5 minutes and I never finish early. Y'all learn that about me? It's just not going to happen. So if you have a line, how many degrees is that?
0.
9. No.
Measure from here to
180.
here.
180.
It's
180. Okay, any skateboarders in here?
No.
The skateboarder does a 180. What are they doing?
Turning completely.
Go back the other way. It's a 180, right? What does it look like if somebody does a 360?
All the way around.
All the way around, right?
I've actually done that on rollerblades.
Oh my. So if you've got, let's say you've got a line that's 180, and let's say they divide it up and they tell you that this angle is 30, can you figure out that angle?
Yes.
Subtract 180 from
What is it, Jamie?
150. 150 degrees.
Did you say it?
150 degrees.
150 degrees. I'll show you one other thing and then we'll stop. You also have something that you can learn about intersecting lines. Don't pack up because you know it makes me talk slower. Yes, ma'am? What do you know about intersecting lines?
Typically, when they intersect, the two sides will always equal the same. So, like, these two white spots will...
Yes. So if they tell you this one's 20 degrees, find X,
It's
what
20
is it?
degrees.
It's 20 degrees. They're called vertical angles, and they're always going to be equal. On the iTed, our point is not trying to get you to get every problem correct. I probably wouldn't get every problem correct if I sat there and did it, okay? And there are much smarter people than me who probably wouldn't get every problem correct. That's not the point. Take the time to learn a couple of these things that you could get one more correct. One more correct. So go back and look at my comments and say, you know what, I don't have to know all of this, but I can pick this one thing. Did you find the videos that I posted?
Mm-hmm.
They're helpful. Look them up and pick one problem and say, you know what, I may not know all of this, but I'm going to pick this one thing. Maybe it's just lines. Okay? Don't panic about that test. Don't panic about that test. Okay? It's just a guide for us and for Tacoma. That's all it is. Okay? Do your best, but don't panic about it. It'll be counterproductive. Yes, ma'am?
Yeah, actually, when a few of us were having a bit of trouble with that, and so us four, Savannah, him, and her, we all made a group chat and we started. It started as a school chat. It's no longer one.
Then we just thought about it and it's illegal.
Yeah.
Well, I think it's a very good idea. It's a lot more fun to do things like that together, and then you can help each other learn, and then you might be taking the iTed and go, oh wait, I remember this. Chloe said this about this one. And it'll help you
Debating
remember.
chat.
You
Okay?
always win me.
Y'all did a great job today. The couple who I didn't get to see your homework, I need to see it. The rest of you can eat. Jamie, you can turn the video off. Or did you already? Thank you.